As we begin with the topic of differential equation, let us understand its meaning. The differential equation is an equation that involves derivatives of the dependent variable with respect to some independent variable. So in simple words, differential equation is nothing but an equation that involves derivatives. So as an example, here there are three differential equations mentioned. We can see that in each equation there is some derivative present. Now we may have derivatives of different orders present in the same equation. So as an example, if you look at the second equation, we see that there is one second order derivative present, that is d square y by dx square, as well as a first order derivative is present, that is dy by dx. In the third example, we can see that the derivative is embedded inside a trigonometric function. Right? So this is also a differential equation. Now with respect to a differential equation, there are two important terms defined. They are called as order and degree. Now let us understand the meaning of each of them one by one. First, we have the order of a differential equation. Now by order we mean it's the order of the highest order derivative present in the differential equation. So basically, looking at any given differential equation, we can easily make out what is the highest order derivative present, whether it is first order, second order or third order and so on. So whatever is the order of that derivative, same is called as the order of the entire differential equation. Right? So that is how we find out the order. Now let's go ahead and understand another important term, that is the degree of differential equation. By degree of a differential equation, we mean it's the degree of the highest order derivative present in the differential equation, provided following two conditions are met. The first condition is that the differential equation can be written as a polynomial equation in derivatives and all the negative or fractional powers of the derivatives have been removed. So let us understand this once again from the beginning. By degree we understand it's the degree of the highest ordered derivative present. Now if you recollect in the previous term, that is the order of the differential equation, we found out what is the highest order derivative. Right? The degree of that highest order derivative is called as here the degree of differential equation. But we have to make sure that these two conditions which are given have been satisfied. So the first condition is that the given differential equation can be written as if it's a polynomial equation in derivatives. Like we have in basic algebra, that we have some polynomial equation in a single variable, say x, and in that we can see the different powers of x present, correct? Similarly here, if we are able to write the given equation as if it's a polynomial in derivatives, then the first condition is met. And secondly, all the derivatives must have non-negative or non-fractional powers. That means they must have the whole numbers as the powers or degrees. So when these two conditions are met, only then we can find out the degree of differential equation. If any of these two conditions is not met, then the degree is not defined for the differential equation. Of course, we will understand everything once again as we see the examples in some time. Also, let us note at the end that order and degree of a differential equation are always natural numbers, right? So they cannot be fractions or they cannot be negative numbers. Now let us solve few examples based on identifying the order and degree of the given differential equation, so that these concepts will be clarified. Now here is the first question, that is state order and degree of the differential equation given by dy by dx the whole square plus 2 dy by dx plus y equal to 0. Right? Now here let us first identify the order. Now visually, which is the highest order derivative present? It is the first order derivative only, which is dy by dx. So therefore order of this equation is nothing but 1, right? Now as far as degree is considered, let us check whether the two conditions that we saw have been met or not. Is this the given equation can be considered as a polynomial in derivatives? The answer is of course yes. We can think of dy by dx as a variable, and it will be clear that it can be visualized as a polynomial in derivatives. And secondly, are all the powers of the derivatives free from negative or fractional numbers? So the answer is once again yes. For the first term, the power is 2, correct? And for the second term, that dy by dx means dy by dx is to 1. So the power is 1. So both the conditions are met. Therefore, the highest degree of dy by dx, as we can see, is 2. So therefore, that's the degree of the differential equation also, right? So that is how we get order and degree for this equation. Now let's see another example. Here we are given d square y by dx square plus dy by dx whole raised to 4 plus 2x equal to 0. Now as far as order is considered, we can see that the first term is the second order derivative. So therefore the order is 2. And for the degree, we check that both the conditions are satisfied, that is it's a polynomial in derivatives and free from negative or fractional indices. So the degree of differential equation is the degree of the highest order derivative, and the degree of this is 1. So therefore degree of the entire equation is also 1. Let us not get misled by the higher degree of 4, although it is higher than 1, but that is the degree of a lower order derivative dy by dx. So therefore that is not the right degree, right? Now let's see one more example. Sine of d square y by dx square plus 3 dy by dx minus y equal to 0. Now here it's not difficult to recognize that the order is 2 because we see the second order derivative. And as far as degree is considered, now here we spot that the derivative is present inside a trigonometric function. So therefore entire equation cannot be considered as a polynomial equation in derivatives. So therefore here, as we have seen, the degree is not defined for this differential equation, right? It simply does not exist. Let's go ahead and see another question. Now here we can see that the order is 2 because we are seeing the second order derivative. Now as far as degree is considered, can we write 3 by 2 as the degree? The answer is no, because it's a fractional power and we cannot have any fractional power. So in order to avoid that, or in order to remove the fractional power, what is the easiest step? The answer is we have to square both sides, because you can see that when we square both sides, what we will get is d square y by dx square the whole cube is nothing but y square. So therefore by bringing y square on the left hand side, we can write the differential equation as d square y by dx square whole cube minus y square equal to 0. Now this is definitely a polynomial equation in derivatives, and now all the powers are free from negative or fractional indices. So therefore now the degree of second order derivative is 3, hence that is also the degree of entire differential equation, right? And now let's see the last question in this type. Alright, here we have dy by dx given as 1 upon d square y by dx square. Now if you observe this right hand side, that can be technically written as d square y by dx square whole raised to minus 1, isn't it? Because that's the reciprocal of that derivative. But then it gives us the negative index for the derivative, which is not allowed in order to find the degree of the differential equation. So now moving one step back, first of all the order can be easily spotted as 2 because we see the second order derivative here. Now in order to get the degree, as we saw, we cannot have the negative index, so therefore the easiest way is to cross multiply, and therefore we will get dy by dx into d square y by dx square is equal to 1, or if you want to bring 1 on the left hand side, we can also subtract it from left hand side and write it as equal to 0. Now we see that this can be thought of as a polynomial in derivatives, and all the degrees or the powers are free from negative or fractional indices. So therefore the degree of highest order derivative, as we can see, it's 1. So therefore the degree of entire equation is also equal to 1. So that is how we find out order and degree of the differential equations.